Now let's just move on further towards the problems, and let's just see the very first question, which says that in a triangle ABCE is the midpoint of the median AD. Show that the area of BED is 1/4 of the area of ABC. So let us suppose if I'm just drawing up the figure of ABC. So this is nothing but the triangle which is ABC, and we have AD being the median. So let us suppose if I'm just drawing the median as AD. So there exists a point E which is nothing but the midpoint of this AD. So now it says BED is actually 1/4. So let us suppose if I'm joining BE over here. So this is actual figure over here. So first of all, since we know that since E is the midpoint of AD, it implies AE should be is equal to ED. So I'm just writing up all the conditions that are given to me, and according to those I'm just writing the conclusions that if E is the midpoint, so AE should be is equal to ED. Furthermore, since AD is the median, it implies BD should be is equal to DC. So let us suppose if I'm calling it as 1, I'm calling it as 2, and I'm just starting up with the area of BED triangle. So I'm just taking area of the triangle BDE. So if I'm taking BED, so we know that this is nothing but half into base into height. So this should be nothing but is equal to half into base, as I'm considering my base as nothing but ED, and I'm taking this one as nothing but my height. So this one has nothing but my height. So BD base is nothing but ED, and height is nothing but BD. Now furthermore, what can we say about ED and BD? We can say that ED is actually nothing but is equal to AE. We can say this thing that ED is actually nothing but is equal to AE, and further for BD we can say that this is nothing but is equal to, it is exactly is equal to nothing but DC. Means in place of ED we can say that this is nothing but ED is nothing but the same as that of AE, and furthermore we can say that this is nothing but is equal to DC. So let us suppose if in place of ED I'm just writing it as nothing but it is half of AD. It is half of AD, because we know that ED is nothing but is equal to AE, and if ED is nothing but is equal to AD, it means that ED is nothing but half of AD. And similarly from here we can say that BD is nothing but half of BC, because it is nothing but a half portion of the whole total. So hence in place of BD we can write it as nothing but a half of BC. Now let us suppose if I'm just taking 1/4 out common, and I'm taking half into AD into BC, then we can see over here that AD is actually existing as a height, and BC is actually existing as nothing but the base. So if we have half into base into height formula, then it is nothing but is equal to 1/4 of the area of the triangle which is ABC, which is nothing but the area of the triangle which is A, B and C. So this is exactly that we have to prove, because here we are taking this as nothing but the height, and we are taking this as nothing but the base. So using this concept we can say that this is actually is equal to the area of the whole triangle, in which we are taking our AD as nothing but the height, and we are taking our BC as nothing but is equal to base. So at the end we have proved that the area of the triangle BED is actually is equal to 1/4 of the area of the triangle ABC, and this is nothing but the proof of this particular question.